Hi everyone.
Hi everyone. In the previous video, we talked about the geolocator plugin not giving us a stream of permissions status changing. And we said that we needed to implement a custom solution for this. And App Lifecycle events comes to the rescue. Erkan, can you explain how does this come to the rescue and what does it exactly do?
Sure, Aytunç. The only way that the user changes the permission status is that the user has to take the app to the background, go to app settings, uh, change the permission status from there, maybe grant it, deny it from there, and then come back to the app. There is no other way that the user can change the app status without uh, changing app lifecycle status. So therefore, we can utilize this for our own advantage and keep our app state in sync with the state of the permission and the actual state. So for listening to the app lifecycle changes, we are going to use the widgets bindings observer class. It gives us a method. It actually has several methods to listen different things, to, to listen to local changes, the metric changes, app lifecycle changes, so routing changes. It gives us several things, but we are going to only use the app lifecycle change in this case. So did app lifecycle state did change app lifecycle state method is triggered when the application's state is changed. Aytunç, can you open the app lifecycle state enum to see what these states could be? So app lifecycle state is the state the application is in. These could be four things. If the user is using the app and the app is responding to the user inputs, then the state is resumed. If the user sees an OS dialog, it could be a permission dialog, it could be a battery low dialog, touch ID request. These things takes the user into the inactive state, take the app into the inactive state. And pause is where the user takes the app to the background and opens settings. In that case, the application is not visible to the user anymore. It doesn't respond to the user input. In that case, the application is paused. I don't think you will ever use the detached state. We haven't ever used it before, so I
I
don't
think
think.
I think it's just
Yeah,
a temporary state while changing in between other states, and it's not a permanent state. You are right. We don't need to implement it, or even if we implement it, it's not going to be too important for our use case.
yeah. I mean, actually, by the way, you can use App Lifecycle in any app. You will probably need in some. I mean, when trying to solve some problem. For example, if you are if your app contains camera, when the user goes to the background, you may want to uh, dispose that camera controller in order to reduce memory consumption. Or if you have an expensive network call and you don't want it to be done when the user is not using the app, then it's wise to uh, stop that request while the app is in background, and when the user opens the app back again, then you can open that request back again. So I think app lifecycle is very useful. So
Erkan,
and you
today,
yeah.
why are we using App Lifecycle? What is it going to solve for us for our particular case?
In our particular case, I mean, as we mentioned in the beginning, it's going to solve the issue of not having a way to listen to the changes in the app permissions state. So when the user pauses the app, goes to the app settings, and changes the location permission from allowed to denied, and comes back to the app, we have no way of figuring it out because we don't have a stream as we have for the location services. Therefore, we need a way to understand this change. So this is where it will be useful. If you want, we can jump into the code and implement the App Life Cycle state, App Life Cycle Cubit.
Sounds good.
Okay, so under the application layer, we are creating a new qubit called Application Life Cycle Cubit. The reason I call this qubit like Application Life Cycle is that they use a very similar naming in their enum called App Life Cycle. So this is the reason that I use a longer naming in order to be not too confusing. Okay,
I see the folder name under application folder Qubit.
I was changing it, but
Okay.
you probably were not seeing it. Okay.
Live share. Yes, it's changed right now. Thank you.
Okay. We created our qubit right now. So in order to use the widget binding observer, here we are going to use it like this. As a mixin, and in the constructor, we are going to use widget bindings dot instance dot add observer. This and also we are going to implement the did change app life cycle state method. So did change app life. Actually, I'm just going to copy the name because it could be confusing. I mean, I don't want to make a typo here. Just the method header. We are going to override this method, and this method will trigger whenever the app lifecycle state changes. Okay. Lastly, in order to not forgetting it, let's remove the observer when the qubit is closed. Remove observer. This. Okay. Before we implement these methods, let's define our state and then come back and finish our implementation there. In this case, we are going to use unions in our state. Just stay with me in this, and I will show you how to implement unions with Priest. You remember we had for app life cycle states which were resumed. Resume. How detached and I think the other one was inactive. Okay, so these are the states, and I think in the free syntax we need to define the constructors like this. If I'm not wrong, these are just syntactic stuff, syntax related stuff, so you don't need to worry about them. You can find the reason for these in the free documentation. So these are not really the things that you need to have in your head without reading the documentation. You can always check them in the documentation. Okay, so we define the state. Since this is a free class, this requires us to run code generation. Let me run the build runner. So while it's running, let's talk about what we are going to do. As I mentioned, this did change app lifecycle state method is going to be triggered whenever the app lifecycle state is changed, and we are going to map whatever they give to our state and keep it in our state. And in the upcoming videos, we are going to use this app lifecycle, listen to this app lifecycle changes, and take some actions depending on that change. Okay, the code generation is now done. Also, I think we don't have an initial state right now, so by default, our state can be resumed, I guess. This is the default state for app lifecycle. Okay, now we can do the mapping and complete our implementation. If state. Oh, this can be confusing because we also have a state in our qubit. Let's call it app lifecycle state. If app lifecycle state is equal to resumed, we are going to emit application lifecycle state resumed. And the other ones will be very similar as well. Let me just copy these and fill them.
Erkan, because in our state class we used union types, we don't need to use copy with method, right?
I mean, we have 4 distinct states in this case. We don't need to use copy with method because we have exactly 4 states. And we are going to emit those states. So we don't need copy with in this case. In this state type, we use copy with. We are creating an immutable copy of the state and then modifying some variables on it. But in this case, we don't have this. We have four distinct states. For other cases as well, inactive, finally detached. Why is this not happy? Oh, says that to name this as state because we are what we are overriding, so it's not happy. I hope the Dart interpreter is smart enough to understand this and not get confused. And if we don't miss anything, this should be all for. Oh, we are missing one. We are going to register this application lifecycle qubit as a singleton, and similar to the permission qubit, we are going to provide it at the top of material app to be for it to be created when the app is uh, app is run, and it's going to be destroyed when the app is destroyed. So this will be a singleton as well. Okay, I think that's it for the application layer. And let's add the providing part as well for us to not forget this in the future. Let me convert it to a multiple provider and create the instance. Import, and similar to the permission qubit, we are going to make it not lazy. Okay, I guess we are done.